Welcome to this A320 Type Rating series, presented to you by the AutoPilots. In this lesson, we are looking at some of the electrical system on the Airbus, before diving into a DC essential bus failure. This lesson is divided into a theory and practical part, so to skip straight to the practical, head to this timestamp. We hope you enjoy. Welcome to this lesson on part 1 of the A320 electrical system. This lesson will cover theory and schematics of the electrics, overhead panel and the ECAM operation, normal operations, some basic abnormal operations. The electrical power system consists of an AC system and a DC system. In normal configuration, it provides AC power, coming from 3 generators, 2 engine generators, and an APU generator. The system can also be powered by an external power source. Some of this power is converted into DC power using the transformer rectifiers. The electrical power has to come from somewhere. For this, we thank the generators. 4 different sources can add electrical power into the system. These sources are engine generators 1 and 2, the primary source of electrical power in each flight. Each generator is driven by an engine through an integrated drive. They are controlled by the generator control units, GCU, which control the output and protect the network. The APU generator and external power is another source. Either can replace one or both engine generators at any time. They feed the AC bus bars, provided they are not connected to the engine generators. The emergency generator. The blue hydraulic system drives an emergency generator which supplies AC power to the electrical system in the event that all main generators fail. This AC power does not go through the AC bus 1 and 2, but instead it is connected to an AC essential bus. And the static inverters transform DC power from battery 1 into AC power. This is then supplied to the AC essential bus. DC current is primarily supplied by the transformer rectifiers, transformer rectifier 1 and transformer rectifier 2. There is a third transformer rectifier, called the essential transformer rectifier, which can power the DC circuit from the emergency generator, if all generators or transformer rectifier 1 and 2 fail. DC current can also be supplied by the 2 batteries, which are connected to a hot bus each. With the current that is generated, this then goes to the bus bars in the system. These bus bars take the current and distribute it to the many other systems on the plane. With so much of the plane relying on electrical power to operate, the role of these bus bars is so essential. If a bus bar is labeled as an S-bus or essential bus bar, then this means that it is essential for a safe landing of the aircraft, and therefore is usually better protected. There is an order of priority when it comes to what source supplies the electrical system. Generators 1 and 2 are the main source of electrical power. In the absence of them, the external power will take over as the source. Even if the APU generator is running, once removed, the APU generator will supply the AC bus bars. Any of these generators can supply the entire network. Even if one of the engine generators has failed, the other will supply everything except for the DC bus entertainment. In a normal configuration, Gen 1 supplies AC bus 1, and this then supplies the AC essential bus via a contactor. TR1 supplies DC bus 1, and this then supplies the DC BAT bus and the DC essential bus. Gen 2 supplies AC bus 2, and then this supplies DC bus 2 via transformer rectifier 2. Batteries 1 and 2 are connected to the DC BAT bus for when they need charging. The electrical configuration will change depending on the failure that's occurred. Should there be a failure of a generator, the other generator can supply both AC bus bars. However, in this case, it is advised in most conditions to start the APU, to reduce the workload of the remaining generator. And in the event of an AC bus 1 failure, the AC essential bus will be powered by AC bus 2. This is done automatically by the AC essential feed auto switching. In the event of one transformer rectifier failure, the electrical system can work with one, and the essential transformer rectifier supplies the DC essential bus. If both transformer rectifiers are lost, then DC bus 1 and 2 are lost. It is only the DCS bus that remains, which is supplied by the essential TR. The failure of the DCS bus can cause a much higher workload, so it's important to break it down into a few, smaller stages. Firstly, as always, follow the Airbus golden rules of fly, navigate, communicate. The automatics are lost, so firstly try to re-engage them, and failing this, establish yourself flying manually. For the navigate part, consider if there are any weather, traffic or terrain near you, which could affect your operations. And to communicate, VHF2 is available, so is ACP3. There is only one way for both crew to hear RT calls. This is because ACP1 and 2 are lost, as is VHF1. So for crew to hear RT calls, the audio switching panel must be set to FO3, and the loudspeaker is turned up to the maximum. When working through the ECAM, a lot of the failures mentioned have a redundancy, or backup, in place, so their priority isn't as high. There are a lot of systems that still remain, such as CPC2, the green and yellow hydraulics, and spoilers 1, 2, 4 and 5. Also a lot of information on the status page, which can initially seem overwhelming, but can be summarized as such. A landing performance is required, due to loss of several systems. Avoid icing conditions. There is no autopilot 1 or auto thrust. You have manual braking only, and you have no GPWS. Another thing to consider is that the high-pressure fuel shut-off valves are inoperative. So engines are shut down using the engine fire push buttons.
Master caution.
Check. Autopilot off. I have control.
Checked.
Re-engaging the autopilot. Removing thrust lock. Okay, so the aircraft is flying with autopilot 2 engaged. I am controlling thrust manually. There is no weather or terrain ahead. We do not need to inform ATC right now, but I will make an attention crew at station PA. Attention, crew at stations. Okay, confirm the failure.
ELEC, DC Essential Bus Fault. This is confirmed on the system's display page, and also on the overhead panel as well.
That's confirmed. I also have offside FM control on my ND, so I can only use the range that you use. ECAM actions.
VHF2 or 3, use. I will use VHF2 for now. Audio switching, select. ACP, FO3 selected. Loudspeaker can be set to max volume.
I can hear ATC communications now.
Checked. Baro ref, check. We both have standard set. GPWS system, off. Avoid icing conditions. Clear ELEC.
Clear.
Auto flight, auto thrust locked.
That's checked. I am flying with manual thrust.
Clear auto flight.
Clear.
Fuel. Left tank pump 1 low pressure, and right tank pump 1 low pressure. Fuel is still being fed to the engines by the remaining pumps.
Checked.
Left tank pump 1, off. Right tank pump 1, off. Clear fuel.
Clear.
Secondary failures. Cabin pressure. System 1 is inoperative. Also vent and extract fans are inoperative. Clear cabin pressure.
Clear.
Hydraulics. Blue system is inoperative, both green and yellow remain, although there is no pressure readings for them. Clear hydraulic?
Clear.
Flight control. Spoiler 3 is inoperative. Clear flight control?
Clear.
Status.
Stop ECAM. There are no resets that we can do. For the expanded checklists, there will be some useful extra information in the FCOM, so we can have a look once we've completed the ECAM. Is there anything else you can think of?
No, there's not.
Okay, read ECAM.
Status page says, avoid icing conditions. If severe ice accretion, minimum speed, VLS plus 10 or green dot. Maneuver with care. We are unlikely to enter any icing conditions. Landing distance procedure. Apply. Engine 1 approach idle only. Both PFD on same FAC. Slats, flaps slow. Cat 3 single only. Inoperative systems. Blue hydraulic, spoiler 3, VHF 1, ACP 1 and 2, wing anti-ice, AutoPilot 1, auto thrust, FCU 1, Cat 3 dual, FAC 1, left tank pump 1, right tank pump 1, alternate braking, revisor 2, cabin pressure 1, vent extract. Clear status?
Clear.
Second page inoperative systems are blue ELEC pump, engine 1 loop A, engine 2 loop B, lead monitoring computer 1, and FCDC 1. Remove status?
Before you do, let's have a quick review of the important systems that have gone, and what we have left. We have no blue hydraulics, but have green and yellow still remaining. We are able to speak to ATC via ACP3, and RMP2 is still available. All transmission and reception equipment on my side has gone. AutoPilot 2 is still available, and I am flying using manual thrust. There is no revisor 2. All the other failures have redundancies, would you agree?
Affirm.
Great. Now let's look at the FCOM. So for the electrical DC essential bus fault, the FCOM says, VHF 2 or 3, use. Audio switching, select. ACP 1 and 2 are lost, therefore, set the audio switching rotary selector to Captain 3 or FO3 to recover communications. Baro ref, check. GPWS off. There is a note here, saying, to shut down the engines on ground, use the engine fire push-button switches. So we can chat about this later. Fuel consumption increased, FMS prediction unreliable, and avoid icing conditions. The rest is the same as the ECAM, and then the other inoperative systems which the ECAM doesn't mention include brake pressure indicator, flight interphone, engine interface unit 2, auto thrust, engine start and revisor inoperative, captain rain repellent, avionics air conditioning valve, standby compass light, high pressure fuel shutoff valves, which is why we need to shut down the engines using the fire push buttons, SFCC1, RMP1, hydraulic fire valves for engine 1 and 2, ram air inlet, ECAM control panel, left loudspeaker, DC shed essential bus.
There's also a note here saying, even if the ECAM status page displays Cat 3 single only, the real landing capability of the aircraft is Cat 2, due to the inoperative auto thrust. Once the approach mode is armed, the FMA displays the correct landing capability Cat 2.
So are you ready for a DODA? D. We diagnosed the issue of a DC essential bus fault, and have discussed the associated failures. O. Options are continue, divert or return. We have Lyon and Geneva behind us. Paris is also about 100 miles to the northwest of us. What are your thoughts?
Paris Charles de Gaulle has good weather, no terrain and 2 runways. 100 miles gives us enough time to set up everything and descend appropriately. We have maintenance there and it makes sense operationally. Lyon and Geneva are very windy, and there is a lot of high terrain, which if we have no GPWS, is an added threat. So overall, I think Paris is the best option.
I agree. This seems sensible. So we will decide on Paris Charles de Gaulle Airport. Assign. I will speak to the crew and the passengers. Could you inform ATC and then set up the MCDU, and do a landing performance calculation? Then we will have a brief, and review this later.
Approach checklist. Baro ref.
QNH 1011.
Seat belts.
On.
Minimum.
520 set.
Auto brake.
Low.
EFB.
Stowed, disconnected. Flaps 1.
Speed checked. Flap 1. Remove status.
No change to ECAM. Remove status. Flaps 2.
Speed checked. Flaps 2.
Lock star.
Checked.
GS star. 4,000 feet set for the missed approach.
Checked.
$2,500.
Gear down.
Speed checked. Gear down.
Flaps 3.
Speed checked. Flap 3.
Flap full.
Speed checked. Flap full.
Landing checklist.
Cabin.
Secured for landing.
Go around altitude.
2,000 feet set.
ECAM memo.
Landing no blue.
Landing checklist complete.
$1,000.
1,000 feet.
Checked.
$500.
Autopilot off.
100. 50, 40, 30, 20. Retard. 5.
Parking brake set. OK. Engine masters 1 and 2 off. Master caution. This has not worked. Let's shut down the engines using the fire push buttons, as briefed.
OK. Confirm engine 1.
Confirmed.
Fire push button pushed. Confirm engine 2.
Confirmed.
Fire push button pushed.